Hi folks, welcome to 4.3 on the division of polynomials. Okay, so a couple of things to remind you of. Today is one of those days where you are taking notes with a video, and I had some suggestions for how you could do that in a way that would help you. So keep in mind that you want to make sure you are actually taking notes while you watch this, that you are pausing when you need to write things down, because I may do things a little bit faster. I may also tell you, hey, pause here and try this. Please make sure you do that. And then lastly, if you're taking notes on your own paper, if this isn't preset for you, then you might want to split your note paper up so that there's 2/3 of it for notes and one section of the margin for questions or ideas or thoughts you have about what we talk about today. Okay, and most importantly, make sure you put this title on your notes, right? Okay, so this is section 4.3 from our textbook, but the topic is division of polynomials. Okay, so first things first, I've got a little warm-up for you, okay? So right now you should pause and write down problems 1, 2, and 3, and they are asking you to factor completely. Okay, so take a moment, pause the video, and factor each one of these polynomials. Okay, hopefully you've come back from pause. So your answers should be x plus 3, the quantity x plus 3, times the quantity x minus 1. You should then get the quantity 2x plus 1 and x plus 5. Just kidding. Just kidding. 2x plus 5 and x plus 1. All right, and then lastly, this guy right here is a sum difference, is a difference of cubes. So we would need to write this as x cubed, the quantity, and then 4 cubed. So we would get x minus 4, that quantity, and then a quadratic, x squared plus 4x plus 16. Okay, and that comes from the fact that we use a minus b and then a plus the opposite sign. A squared plus ab plus b squared. So it's always the same sign, the opposite sign, and then that last one's always positive. Okay, so now you may be wondering, why am I starting off with factoring when I told you that today we're talking about division of polynomials, right? We're talking about the divide symbol. Well, you might not believe this, but division or factoring is really just division. Whoa, mind blown, isn't that crazy? Okay, now you might be thinking, I don't understand, Mrs. Fry. Okay, well, let's take the number 20, okay? 20 is 2 times 10. You could also say that 20 divided by 10 is 2, right? It's just sort of a reorganization of your information, right? If you divide by a factor, you get the other factor. So if we take a look at number 1, if we take a look at x squared plus 2x minus 3, we said that that is x plus 3, that quantity, times x minus 1. Well, get this. If I took x squared plus 2x minus 3 and I divided it by x plus 3, that would give you x minus 1. Now, you're probably thinking, I don't understand how that works. Well, I'm going to show you why that's true. But a really important thing for you to take away from today is really that division is sort of just another way to factor, okay? But it might be used for when you're not sure how to factor something. So today's goal is that we are going to apply 2 ideas. One of them is long division, just like you long divide numbers, and one of them is called synthetic division in order to divide polynomials, okay? All right, first things first, long division uses this symbol that kind of looks like a square root, and remember that we put the divisor on the outside and the dividend inside, okay? So the setup for this very first problem is that we have this cubic polynomial divided by a linear. So we're going to put x minus 1 on the outside. And then we're going to put x cubed minus x squared minus 2x plus 8 in our divisor. And so keep in mind there's a 1 there. That's a -1. This is a -2. and a positive 8. Okay, those coefficients are going to be important. All right, so here's the idea. What we're going to do is one term at a time, we are going to try and eliminate each term by adding to 0. So for example, I'm going to start by writing x squared up here, because if I take x squared and I multiply it by x, that gets me x cubed. And when I subtract those two terms, I'm going to get 0, which is good. I want that to happen. But here's the thing. You understand distribution. I can't just distribute to one term. I have to distribute to everything. So I would also get a negative x squared. Now, because I'm subtracting everything. So that ultimately means my first term subtract out, because x minus x, that gives cubed, gives me 0, x cubed. And then I also distribute that negative here, so I get a positive x squared. Those also add to 0, x squared. Sometimes that happens, sometimes it doesn't. If it doesn't, we would just get rid of it, but now we can actually carry down our next term and ask ourselves the same question. What would I multiply x by in order to eliminate negative 2x? Well, I would need a negative 2, because that gives me the identical factor. But then remember, in division, long division, you're always subtracting whatever you are taking out. So I'm going to get negative 2x, and then I also have to distribute my negative 2 to negative 1. So I'm also going to get positive 2. And just to make it a little bit easier, I'm going to carry that 8 down as well. Okay, so my negative 2, this ends up being addition, because a negative times a negative, so those are gone. That's 0 x's, which is what I wanted. And then 8 minus 2 leaves me with 6. Okay, now after this, because I just have 6, not 6x, there isn't anything else I could write up here that would help me get rid of this 6. So I'm done. So my answer is that when I take this polynomial, divide it by x minus 1, I get x squared minus 2 and a remainder of 6 over x minus 1. All right, that's my remainder because it didn't divide evenly. And sometimes that's going to happen. Sometimes it'll divide evenly and sometimes it won't. Okay, so I'm going to set up this next example for you. X minus 4 is our divisor, then x cubed is our dividend, but notice I'm missing some terms in the middle. I'm missing an x squared term and an x, but I have my constant at the end. So it's important to put these terms here as placeholders to keep your work organized in different columns, okay? So again, I'm going to try and think about what can I multiply x by to get x cubed? Well, x squared would do the trick, and then I distribute that, so I get x cubed minus 4x squared. And then remember, I'm subtracting everything, so I get 0x cubed, and then I get positive 4x squared because a negative times a negative gives me a positive. All right, what could I multiply x by so that I get 4x squared? Well, 4 and an x. So I get 4x squared minus 16x. Again, I'm subtracting everything, so those first two terms are gone. And then I distribute, so I end up getting positive 16x. Here, I'm going to carry this all the way down. Negative 64 is down here also. What could I multiply x by so that it looks like 16x? I could multiply it by 16 and negative 64, and then when I subtract, everything's gone, so I get 0. That means I have no remainder. Woohoo! I like it when that happens. Okay, what does that mean? That means that x minus 4 really is a factor, and check this out, guys. I did this intentionally. X squared plus 4x plus 16. Look, x squared plus 4x plus 16. This is our answer here. I'm going to write it, I have just enough space. X squared plus 4x plus 16. And you could say plus 0 over x minus 4, but this is not required. Okay, notice we got a perfect factor. So if you ever forget that cubes formula, you could always just like divide and figure out what the other factor is. All right, we've got 2 more examples. Now, I want you to take a moment and try and set them up. In fact, maybe try number 4, and then I'll explain number 3. Okay, so pause the video and try these 2 problems on your own for a moment here. All right, hopefully at least you've got the setup part down. We're going to start with number 4. 2x plus 3 outside as our divisor, and then 2x cubed plus x squared minus 43x minus 60 goes inside. Okay, so again, what do I multiply my first term by to get my first term? In my big polynomial, in this case I already have 2, so I just need a 1 times x squared. So I get 2x cubed plus 3x squared. And then remember, we're subtracting the whole quantity. So we distribute that negative. So the first terms are gone, and I'm ending up with negative 2x squared. And I'm going to bring down the negative 43x. Okay, next term to knock out is this negative 2x squared. So I need a negative number. I've already got my 2's matching up, so I think I just need a negative 1x. So it's going to give me negative 2x squared and negative 3x. And then remember, that means I'm going to subtract everything. So those are gone. And then I'm really adding. So I get negative 40 minus 60. Negative 40x minus 60. All right, and then how do I get 2 to turn into negative 40? What product? I need to multiply by not negative. Wait, yes. Negative 20. All right. So then I multiply by negative 20, and I get negative 40x, and I get negative 60. Check that out. When I subtract, these both become positive. So I have a remainder of 0. So my answer is x squared minus x minus 20. That's what I get when I divide. And look, that might even factor. You might even be able to find out all the factors of that particular third degree polynomial. All right, last long division problem for the day. It's a little bit more complicated because our divisor has more terms. And 2x to the 4th, 3x cubed. I'm missing a squared term, so I need a little placeholder. Very important to keep track of that placeholder. Okay, so I need an x squared, so I get, and a 2. I get 2x to the 4th, and then I get 6x squared. I'm going to line it up so that it matches up with my terms. Oh, I'm so sorry, guys. I get 6x cubed, because that's to the first power, and then I get 2x. Sorry, 4x squared. Sorry, and then I distribute the 2x squared. Okay, so I'm subtracting all of these terms. So negative and a negative. 3 minus 6 is negative 3x cubed. And then negative 4x squared. And then plus 5x. All right, now I need a negative 3x. So I get negative 3x cubed. I get negative 9x squared. And I get negative 6x. Okay, again, I'm subtracting. So that switches to positive, so those are gone. Switches to positive, so I get 5x squared. Switches to positive, so I get 11x. And then don't forget there's this negative 1. All right, last thing, I think I need a 5. 5x squared, 15x, and 10. Remember, I'm subtracting everything. First term's gone. I get negative 4x and negative 11. Okay, so I had a remainder. So my final answer is going to be 2x squared minus 3x plus 5. And then plus negative 4x minus 11 over x squared plus 3x plus 2. So this is our remainder. All right, so we had a remainder. That means that that quadratic I wrote is definitely not a factor of my polynomial. All right, other topic to talk about today. By the way, long division works every time. And what do I mean when I say works every time? I mean you can divide any polynomial by any other polynomial as long as its degree of the dividend is greater than the degree of the divisor. Okay, but you can use long division anytime. Synthetic division, not true. Only possible for linear factors where a equals 1. Okay, that's the only time you want to use synthetic division. So notice I've got x minus 1. That's a linear factor. And here's what you do. You solve equal to 0. So like solve this equation, the factor, when it's equal to 0. And maybe I should say instead of solve, because I don't want you to get confused. This isn't a solving technique. Set equal to 0 and solve. So what does that mean? That means I'm looking at x equals 1. Okay? So what I'm going to do is I'm going to take my root. We'll call that my root or my x-intercept. And we are going to divide it through. And we are only going to put the coefficients in this time. So this is a number 1, but I'm doing it with the other method. So our coefficients are 1, -1, -2, and +8. Okay? And here's what you do. You drop the first one. So this guy, you just drop it. All right? And then from there, you multiply. So I get 1 times 1, which is 1. And you add. So that gives me 0. And then you repeat. 1 times 0 is 0, and then you add, so I get -2. 1 times -2 is -2, and then I add, so I get 6. And whatever's here is your remainder. And then our answer, this guy right here, is 1x squared because it's 1 degree less than our original polynomial. So plus 0x minus 2 plus 6 over x minus 1. So if you look at that, it's the same answer. All right, so we're going to try that same thing over here with -x cubed plus 4x squared plus 9 divided by x minus 3. So kind of think, ooh, set that equal to 0, so x equals 3. That is our root that we're using. Then we're going to use our coefficients. And same situation, you may need a placeholder because there's 0 x's in this problem. And then 9. All right. And then same process as before. Drop the first term coefficient down, and then multiply, and then add, and then repeat. Multiply and add. Multiply and add. All right. So it looks like we are going to get -x squared plus x plus 3 plus 18 over x minus 3, because that is our remainder. So what does that mean so far? So far, both the things we divided by were not factors of the polynomial that we were looking at. All right, you guys try, sorry if I just hit my mic, example number 6 and example number 7. So pause your video and give those 2 problems a try. All right, welcome back. Here you go. Here are your answers. You should have divided by -2, 1, -3, -7, and 6 were your coefficients. And then we got a remainder of 0. Yay! That means x squared minus 5x plus 3. That's our leftover quadratic, and that means x minus 2 or x plus 2 was a factor. All right, dividing by -1, that's the root we're going to use. 2, 7, and 5. Drop my 2, -2, 5, -5, 0. Hey, check that out. This one's also a factor. All right, so in both cases we had a remainder equals 0. Then the root is a 0 of the polynomial. All right, another usage for synthetic division is to evaluate at a polynomial. So here's the thing, this problem right here, example number 1, You might think, well, that was useless, all of that work. But it turns out that for that problem, if I substitute in 1, so like f of 1 must equal 6, because that was our remainder. Or over here, f of 3 must be equal to 18. Okay, so basically, what we can discover is that if you want to figure out like f of -4, you could synthetically divide by -4, and that's going to give you your outcome. So instead of having to substitute it in and do all the calculations, you can actually use this as a tool if you don't have your calculator or want to deal with those really big perfect squares. So this is 84, and that's 97, and then we've got -360 and -28. So it looks like -388. All right, so we're looking at -359. So that means f of -4 must be -359, because you're pulling your remainder in there. All right, try that last one. See if you can evaluate at 2. So basically, we're figuring out f of 2 equals blank based on our synthetic division. All right, so if I divide through 2, 5, 2, -20, -6. Wait, we're missing a term. We need 2, and then 0, right? Because we're missing an x cubed. Sorry, x squared, I should say. All right, f of 2 should be 50. Hopefully I didn't miss a negative or a positive. 5, 10, 12. Yep, looks good. All right, so ladies and gents, a couple of things. Synthetic division can be used sometimes. Long division can be used all of the times. Thank you for sticking with me and listening through to this video. I know this was a bit of a long one. I'll try to keep them short as possible in the future. Hopefully you followed some of these tips. Don't forget to ask those questions. Check in if you need any assistance. Again, thanks for being here today. Have a good one. Bye.